In the sweltering month of August 2026, major power grids across multiple continents began to fail at the exact same time. A severe European heatwave pushed electrical systems past their operational limits. In Hungary, water levels on the Danube River dropped so low that the country had to shut down its only nuclear plant, which relied on the river's water for cooling. Across the Atlantic, aging infrastructure and thunderstorms plunged Cuba's 10 million residents into a 36-hour blackout. The capital city of Havana went completely dark. Meanwhile, in Nigeria, Africa's most populous nation, the national electrical grid suffered a total system-wide collapse, cutting power to major metropolitan areas like Lagos and Abuja for the second time in less than a week. These parallel blackouts reveal a structural flaw in modern energy distribution. Massive, highly centralized national grids are uniquely fragile. When one critical node is compromised by weather or mechanical failure, the entire system cascades into darkness. This chart visualizes the severe gap in Nigeria's power supply. To adequately fuel the nation's economy requires an estimated 30,000 megawatts of electricity. Yet the actual output from the grid struggles to reach 5,000 megawatts. To survive the deficit, businesses and households are forced into a shadow generator economy. They rely on a chaotic network of private petrol and diesel generators just to keep their lights on and factories running. This flowchart illustrates a destructive cycle known as the utility death spiral. When power becomes unreliable, high-paying industrial customers defect to self-generation. The public utility then loses its most critical revenue source, which causes them to defer maintenance. The grid decays further, outages increase, and even more industries abandon the system. Instead of investing in the public grid, manufacturers now spend over 45 trillion naira annually on diesel and captive generators, draining vital capital away from the infrastructure that needs it most. But one Nigerian commercial hub found a way out. ABBA, a city of roughly 900,000 people, intentionally built a wall between its own power supply and the national grid. ABBA represents a test case for a different approach. Rather than repairing the national grid, the city built a localized system to function without it. This animated map outlines a strategy called ring fencing. It works by taking a specific urban zone, physically severing its connection from the sprawling national transmission line, and closing off its own independent power loop. For ABBA, the anchor of this strategy is Geometric Power's 188-megawatt gas-fired plant. It's a privately funded generation facility built specifically to serve this region. The city paired this local generation with a network of smart meters and a private distribution system. By building both, ABBA entirely bypassed the Federal Transmission Company of Nigeria. While the rest of the country endured chronic blackouts, ABBA enjoyed 2 straight years of highly reliable, uninterrupted electricity. By keeping the electricity close to where it was generated, the city showed that reliability can be achieved by granting a localized operator total control over both generation and distribution. Then, in August 2026, the reliable city of ABBA suddenly lost power. But this was not an electrical grid collapse. The power plant itself was fully operational. The fuel supply feeding it had failed. A 50-year-old clutch gear and starter motor gave out at a gas gathering plant in neighboring River State, cutting off the natural gas required to run the turbines. When a centralized national grid collapses, the response is usually bureaucratic. Politicians point fingers, agencies issue press releases, and the underlying issues remain untouched. ABBA's private operator took a different approach. Because their revenue depends on keeping the lights on, they immediately chartered a direct cargo flight to rush replacement parts from the United States straight into Lagos. Hardware will inevitably break. The true advantage of a decentralized microgrid is that the financial incentive to fix problems quickly and transparently is baked directly into the system's design. ABBA's outage ended once those replacement parts arrived from the US. National grid failures, however, persist because they are rooted in decades of underinvestment and rotting infrastructure. ABBA's ring-fencing strategy offers a scalable blueprint for the rest of Africa's energy infrastructure. For years, governments have poured billions of dollars into reviving unmanageable, aging transmission networks. That strategy is a massive sunk cost fallacy. Energy independence for developing nations will not come from just patching up monolithic systems designed a century ago. It will come from empowering local communities and private enterprises to build and manage their own resilient microgrids.